Hello everybody and welcome back. We're on question number 2 of the 2008 Galois paper. And we've got 4 parts here, A, B, C, and D. It doesn't look like they're setting anything up, no explanation ahead of time, unlike the O'Hara triple question up above. It just looks like straight geometry, I think. Determine the equation of the line passing through points P and Q, where P is 0, 5 and Q is 6, 9. This is sort of basic grade 9. Get the slope and either use the y-intercept, which P is, or use one of the 2 points and use like point slope form, something like that. Now there's 4 parts. I'd kind of like to see where they're going in case I can deduce things along the way. B. A line through Q is perpendicular to PQ. Determine the equation of the line. Alright, well we've got a point on it that's Q, and we have to understand the relationship between perpendicular lines. Their slopes are negative reciprocals. That's not going to be that bad. The line from B crosses the x-axis at R. Determine the coordinates of R, and then determine the area of right-angled PQR. Alright, that doesn't seem so bad. We'll end up with a nice little picture, but it seems to be sort of a logical progression. Get line, get other line, find the intercept of that line on the x-axis. It shouldn't be that bad. Alright, let's go to our notepad here. So for A part, well, let's get the slope of the line. That's going to be, you pick either y-coordinate to start off with, so we might say Q is y-coordinate, which is 9. So 9 minus 5. All you have to do is keep the order the same, so 6 minus 0. And that'll be 4 over 6, or 2/3. Just want to make sure I got the numbers right. 6, 9, 0, 5. Yep. Difference in y's over differences in x's. Okay. Now the y-intercept is going to be 5. Says P is on the y-axis there. A little explanation. Therefore, PQ has equation y equals 2/3 x plus 5. Now, having already read the rest of the question, and knowing how important it is that I get this line right and its slope, because then that determines my answer to B, and then that determines my answer to C, and that'll affect my answer to D, I might stop for a moment and double check, are P and Q really on this line? Just to make sure. Well, so we'll do a little sort of side calculation. P has x is 0, so 2/3 times 0 plus 5 is 0 plus 5. And that will, in fact, be 5. So 0, 5 is on the line. More importantly, 2/3, 6 plus 5. 6 divided by 3 is 2, so that's 2 times 2 plus 5. And that's 4 plus 5. And that is, in fact, 9. So 6, 9 is on the line. We've got both of these. Okay, just a little extra insurance before I get into any of my other calculations. So how would we answer B? Well, I would just state the fact that perpendicular lines have slopes which are negative reciprocals. Oops, negative doesn't have a Q in it. Okay. So the slope of the new line is -1 over the slope of PQ. But we worked that out in the previous question. So that's -1 over 2/3. Reciprocal of a fraction means you flip the fraction. And the minus sign stays where it is. Okay, so we've got -3/2. And it passes through Q. Now, you could just use point slope form of the line. So if you wanted to, you say y and then minus the y-coordinate of the point you've got. And then slope times x minus the x-coordinate of the point you got. And that's a fine answer, but we gave our original answer in y equals mx plus b form. So it might be kind of nice if we kept it in y equals mx plus b form. Additionally, I find that as time goes on, point-slope form isn't really done in high school that often, so you might be saying, well, what form of the line did you just do there? It's called point-slope form of the line. It's useful a little bit when you get to calculus, but most people know y equals mx plus b, so let's answer that way instead. So how would I do it if it was y equals mx plus b form? Okay, well, we're looking like y is negative 3/2 x plus b. Q, which is 6, 9, is on the line. So that means 9 is negative 3/2 6 plus b. Well, that's going to be negative 3. 6 divided by 2 is also 3. So that'll be negative 9 plus b. And so rearranging, bringing the 9s to both sides, 18 is equal to b. So that's y equals negative 3/2 x plus 18. Okay, so that's the slope of our other line. And now for C part, they wanted the x-intercept, right? Crosses the x-axis. So R is on the x-axis. Therefore, R has a y-coordinate of 0. So let R be at, let's say, x0. Actually, I'm going to call it a0 just so I'm not confused with the x's in my equations. So that tells me 0 is negative 3/2 a plus 18. Multiply everything by 2. Negative 3a plus 18 times 2 is 36. We'll bring the negative 3 over to the other side. 3a is 36. Divide by 3. A is 12. So R is at 0, as at 12, 0, not 0, 12. Okay. Now this 12 here makes me remember P is at 0, 5 and makes me start thinking 5, 12, 13 right angle triangles. I don't know if we're going to need this, but we'll see. I'd like to draw a picture because now we have to figure out the area of a triangle. Area of PQR. So let's draw a picture here. Everything's up in the first quadrant. So let's say P is about here. And Q, let's go over, so let's say 6 is here. Up 9 is about here, so let's say that's where Q is. And then R is about here. Okay, so we want this guy right here. And we're told that this is right angled. Okay. Now let's see here. I just want to draw attention to the fact that we do have a 5 here and a 12 here, and that tells me that this is 13 here. It's a common Pythagorean triple. 5 squared plus 12 squared is 13 squared, and one must never forget the axes are perpendicular to each other. That's what makes some really nice things in linear algebra happen. But that's in your future. Now that doesn't guarantee that this is a 12 and this is a 5 here. That's not a guarantee by any means. But it'd be really nice if that were the case. So I know what PR is. Does that actually matter? I don't think so. I think I just need to figure out PQ and QR. I will include this as a little side calculation that PR is 13. Just in case I find that relevant. I'm trying to avoid just using the distance formula is what I'm doing. I'm sort of trying to stop and think, is there a cleaner way to do this? Do I recommend you do that on a contest? No. If you know a way to do something and it's not too much of a hassle, a little bit of a hassle, go ahead and do it, because the time you spend, like what I'm doing right now, the time I'm spending wasting trying to think, is there a nice clean way to do this? That's time you're eating out of question 3 and 4. And you want to save as much time, especially for question 4, if you're going to try for it. So, alright, let's abandon the search and just say, so PQ is the base, QR is height. So PQ is the square root of, excuse me, the difference in the x coordinates squared and the difference in the y coordinates squared. You don't actually have to keep the order the same. I just tend to. Not when we're squaring, because any change in the order will just be at the cost of a minus sign, which goes away when you square. So that'll be 36. Oops. 6 squared is 36. So it looks like PQ is bigger than 5. 36 plus 4 squared is 16. And that... Oh, you know what? No, I do. I was about to say I just need PQ squared, but I don't. So it's going to be square root of 52. If you want to, pull out a factor of 4 and square root it to get a 2. 2 root 13 here. That's fine. That does tell me that this is going to be 3 root 13, but let's compute it anyway. So it'll be 12 minus 6 squared plus 0 minus 9 squared. That'll be 6 squared, 36, 9 squared, 81, and that'll be 117. Which you can divide by 9. So 1 9 goes in there, and 3, and then the 9 comes out. Instead of square root 9, we tend to just write 3. Okay. So I was right. How did you do that in your head so fast, you might ask? Well, because I already saw the 5 and the 12 here, so I know this is 13. 2 root 13 plus something. 2 root 13 squared is going to be 4 and a 13. I need something times a 13, because when we square 13, we get 13 times 13. What do I have to add to 4 to get 13? 9, so there we go. And so square rooting, you get 3 root 13. So that's how I was able to do it so fast in my head. But the point is, we've got these distance formulas, so now what can we do? We say, since PQR is right-angled, the area is going to be 1/2 base times the height. So 1/2 2 root 13 times 3 root 13. The 2's will cancel. The root 13's become a 13, and 3 times 13 is 39. There we go. Not so bad, really. And that's it. Determine the area of right angle. They even tell me it's right angled for PQR. But we could have deduced that because QR was made to be perpendicular to PQ. Alright, so that's question number 2. Hopefully you got it or got most of it, and if you didn't get all of it, hopefully having watched it, you fill in some of the gaps in your knowledge. You might learn a different way to do things. And yeah, I'm going to leave it there and go on to question number 3, which I will put in the next video.